All right, welcome back to the next video in our series of distance learning for Algebra 2. Today we're going to be talking about solving equations with radicals and rational exponents. I'm actually going to break this video up into two smaller videos, but I don't want to make one like gigantic long ones because I've got a bunch of examples in this. So it's going to be in two parts, and I'll link to the other part to the second video down in the description. Good idea to have a piece of paper and a pen or pencil with you to kind of work through the examples. Not a whole lot of notes really in this, but just kind of process-wise on what to do. Okay, so let's go and get into it here. So what do these equations look like? So obviously with a radical, you're going to see the radical symbol. You might see a square root, you might see a cube root. You could even see higher powers. They're not quite as common, so we're going to mainly stick to the square roots and cube roots, but it could be something higher power. You might see a radical on both sides, you might just see one on one side. There's kind of different combinations that you want here. The second half of the second video I'm going to do is going to be dealing with rational exponents. We're going to do them the exact same way, but again, that'll be in that second video. Okay. So what are the steps? So the first off we're going to get the radical term by itself. Whatever that radical thing, we're going to make sure that's by itself on one side first, and then we're going to kind of move on from there. To get rid of that radical, we're going to raise both sides to the power equal to the index. Okay, we talked about the index last week when we did the exponent rules. If it's a square root, you'll raise both sides to the power of 2. If it's a cube root, both sides to the power of 3, and so on up the line. If you had a fifth root, you raise both sides to the power of 5. Okay? And then we're going to just keep on solving for x. Now, sometimes there just may be what we call a linear factor of x. So you just solve, get x by itself like normal. If you see a higher power of x, then there's going to be some factoring going on. You may have more than one solution. Okay, just like before the rational functions a couple of weeks ago, it is going to be important that we plug the solutions back in to check for extraneous solutions. Okay, some of these things may not have any solutions at all. Some of them you might find two solutions, but one of them may not work, so it's important that we do that each time. Okay. So let's go and jump into an example here. So I'm just going to start off easy and then kind of progressively a little bit more complicated, but it's really going to be the same process all the time. Okay, so the first one we have root of x plus 1 equals 4. So notice in this case, the radical is already by itself, and because it's already by itself on the left-hand side, so that's fine. So we need to square both sides. So it'll look like that if you're writing it down. And then we're just going to clean it up. Of course, whenever this happens, the square and the square root cancel each other out. So that's what I just call cleaning it up. So it's going to be x plus 1 equals 16, of course, 4 squared. And then just get x by itself. We know how to do that. So x is going to be 15. And I'm going to go back and check that answer. And I'm going to put 15 in to the left-hand side there. So the square root of 15 plus 1, obviously root 16. And that's of course equal to 4. So that checks out. So that's our final answer. We're done. Okay. So let's take a look at another example. So now we have this. We have a cube root now. But again, it's already isolated. So, but this time, instead of raising it to the second power, we need to raise it to the third power, which we call cubing both sides. Okay. So again, it'll look like this. The third power on both sides. We're going to clean it up again. The cube root and the cube cancel each other out on the left. So we have 2x minus 9 equals 27. 3 times 3 times 3. And then we're going to we're going to add 9 to both sides to kind of continue solving for x. Then we get 2x equals 36. 37 plus 9. And then divide that by 2 to get x equals 18. And again, we're going to need to check that answer just to make sure it works. So I'll just did it here in one step. So 2 times 18, we plug it in for the x. So 2 times 18 minus 9, that's 36 minus 9, which is 27. And again, the cube root of 27 is equal to 3, so it checks out. So my final answer is x equals 18. Okay, nothing crazy so far, right? So let's go and look at the third example. So now we have this. We have -3 and then square root 5x plus 1 equals 18. This is the time where you need to isolate the radical first, okay? Now there may be some other things going on, but this is the example that we have here. So the first thing we have to do, we have to divide both sides by -3 to isolate it, okay? So we do that. So 18 divided by -3 is -6. So now we have the radical 5x plus 1 equals -6. And now we can square both sides to get rid of the radical. So we have 5x plus 1 equals 36. Remember, -6 times -6 is 36. Subtract 1 from both sides, you get 35. And then divide by 5, of course, as x equals 7. Okay? So let's check this answer and see what happens. And again, I'm plugging in kind of all at once, but you see here, if I plug in 7 for this, so 5 times 7 is 35, plus 1 is 36. We know that square root of 36 is 6, but look here, -3, that thing out front, -3 times root 36, or -3 times 6, is -18. That ain't 18. So they're not the same thing on both sides. So that means that's really not a solution, which we call extraneous. So if you had this on your paper, you would just write no solution and be done with it. Okay. So again, you may not kind of realize right off the bat that it's an extraneous solution. You might not be able to recognize that, but if you check it by plugging it in, then you can see when that happens. Okay. So let's do one more example and take a look and see one with 2 solutions, or maybe 2 solutions. So again, so here we have x plus 1 equals the square root of 7x plus 15. Okay. Again, the radical is already isolated on one side, so that's fine. So we're going to square both sides right off the bat. On the left-hand side, it's fine. Or I'm sorry, on the right-hand side, rather, the square and the square root cancel each other out, so we just have this, right? But then we got to square x plus 1. And remember, don't forget your algebra 1, folks. So we have to either do 4 the box method or whatever it is you do on the left. So that's going to become x squared plus 2x plus 1 still equals 7x plus 15. But if you remember, I said at the beginning of this video, here we have a higher power of x, right? So this is not just as simple getting it by itself. Now we have to get everything on one side and factor what's left over, okay? So I'm going to subtract 7x from both sides. I'm going to subtract 15 from both sides. And I'm going to have x squared minus 5x minus 14. That's something that we should be able to factor. Okay, so we can factor that to x minus 7 and x plus 2. Watch your signs there. And of course, that would mean x equals 7 and x equals -2. So there's our 2 solutions, right? Happy days. But we got to go back and check our answers. So if we check the first one, if I plug in +7, and remember, plug it in for anywhere there's an x, right? So on the on the left-hand side, 7 plus 1 is 8. And on the right-hand side, 7 times 7 plus 15. So on the left-hand side, we have 8. On the right-hand side, we have root 64. And of course, root 64 is equal to 8. So that's 5, right? So 7 is definitely an answer. But let's take a look at this. So -2 plus 1 on the left, if I'm plugging in -2 this time. And then on the right, I've got 7 times -2 plus 15. So this becomes -1 equals the square root of +1. That's not the same thing, okay? So -2 is an extraneous solution and is not going to be part of that. Okay, now I know some of you might be saying this, well, wait a minute. I remember you saying in class over and over and over again, anytime you ask about the square root, it's always plus or minus. So wouldn't -1 really be a square root of 1? Yes, but it's not a solution. If you were to graph this like on Desmos or something like that, then you would see there is only one intersection between if you graph x plus 1 on one equation and then the radical 7x plus 15 on another equation, okay? So x minus 2 is an extraneous solution. We have that one solution, okay? I'm going to go ahead and stop the video here. In the second part of this video, there are going to be, I'm going to give 2 more examples on solving equations with rational exponents instead of just writing it as a radical. And then there's also going to be 2 more problems for you to do by yourself, both like this and with the rational exponent. Okay, so I'm going to stop this video here. If you want to start the assignment and see what you can do on it, by all means you can do that. Feel free to contact me via email if you have some questions. If you have some other folks, if you have some friends of yours, some classmates, feel free to share the video and subscribe and all that fun YouTube stuff. Until the next time, I hope you guys are doing well. Hope your family's doing well. Stay well and stay safe and keep studying.